You guys have beer? No beer? No. Yeah, we'll talk more about beer later. So at any rate, thank you. I was a student, went here, I think this was a library when I went here, so I'm probably dating myself a bit. I'm going to talk about sort of STEM from a perspective of a president CEO. Because I think that maybe you just take a show of hands here. How many people want to be software designers or in technology? Anyone want to be a manager, director, vice president? Anybody a manager, director, vice president now? All right, you got some already. Okay, so I'm here to tell you that, and we'll talk more about this, but I'm here to tell you that the path you're on now, whether you believe it or not, is a terrific path. And I'll tell you why in about 25 minutes. Okay? Are you in technology? Okay. What grade are you in? Sixth grade? Are you taking classes here? Just having pizza. All right, fair enough. Just good. Okay, so here's what I want to talk about. I mean, the first thing is sort of my journey, sort of, kind of why I'm here. Maybe there's kind of a combo platter. Hey, I went here, but there's really a intrinsic reason why I think I want to get back to you guys and help you understand that there's a great path for you guys. What I do today, because that will help you understand a little bit about solution and technology I want to talk about. There's kind of inherent in STEM is this whole notion of trial and error and kind of this whole scientific method. I want to talk about a solution that we incubated, funded, turned on, and we grew to $80 million in 2 years. And it's in the IoT space. Anyone hear of IoT or Internet of Things? No one's heard of Internet of Things. One person. 2 people. Okay. We'll talk about it. And it's about beer. So maybe it's one of the examples of the teachers in one of the use cases. And then I want to talk about success. Because I think success comes in many different ways, and I want to bring that back to why I think you guys are interested in viable path. And then we'll do Q&A. So can you guys hear me okay back there?
Yeah.
Yep. Fine? Do I need a microphone?
No.
No? Yes? I do need a microphone. Okay. I gotta do this. Okay. All right. So let me tell you about my background. I was born here in California. In fact, I didn't live too far from here. Maybe many, like you guys, I came from a blue-collar work ethic. My parents didn't go to college. My brother and I, the first to go to college in our family. I went here, graduated in '85, went to Secretary of State, graduated honors in 1987. I don't know, maybe unlike you guys, maybe this kind of connects, but I had a learning difference. I was ADHD, so I was really fidgety in classes. Let's see too many people moving around. There you go, right there. So I was, and still am, dyslexic, so I had a lot of challenges. And I think the combo platter of all of that, given sort of how hard it was and how expensive it was, Kenyatta was sort of my savior. It was free, basically. And I went to San Francisco State and it was expensive. It was $187 a semester. That included books and medical care. So that was expensive for me back then. Started my career in advertising. We'll talk more about that. And I've done a bunch of things, mostly all technology companies, including when I was at advertising. I did advertising for technology. And inside sales management, executive management, COO, and also president. We'll talk more about where. And I've been at Wyndham now for 10 years. Wyndham was a publicly traded company. We were bought by Intel, and we're a wholly owned subsidiary. I've got 2 kids, like the outdoors, fitness, and spending time with my kids. So got a son that plays soccer, so she's busy on the weekends. And I have a daughter doing a semester abroad in Switzerland. So she's college age. All right, so professional background. This gives you just a perspective of where I work. So, I've got a varied background. I think this really helps. So, for those of you guys are looking at doing different things, I think it really, really, really helps you to get a diverse exposure to things. Because at the end of the day, a lot of this has to do, when we think about executing and doing terrific, sort of going from insight to execution, your ability to bring in your perspectives really helps. The more you can have, the more experiences, I think helps. So, Wind River. Who's heard of Wind River? One person. Two people. So, just to tell you what we do, we sell a software operating system and middleware to the 95% of computers that aren't personal computers. And we have software on 3 billion plus devices. So planes, trains, automobiles. If you've been who's been in the hospital? Yeah. Ever had an X-ray, MRI, fluoroscope? We're 99% of all 3 of those devices. Meaning that if you were X-rayed, if you were, radiated with an MRI system, you used our software to make sure it was safe. We're a wholly owned subsidiary. We did $426 million last year in revenues, nearly 2,000 employees, 800 software engineers, offices in 24 countries. We work heavily in automotive, so I know most of you either driven a car or have a car. Anti-lock braking systems. When you turn your car on, you know how fast a car needs to boot up? Anyone take a guess?
No.
You're wrong. You guys know? Come on, take a guess. You guys know microseconds and milliseconds. Anyone take a guess? Not bad. It's 60 milliseconds. So that's a lot faster than any PC I know from cold start. Right? Cold boot. And 95% of the world's mobile traffic between the base stations, so from Cisco, ALU, Ericsson, Huawei, these companies, these are software to route traffic. And we were voted one of the best places to work in 2015. Okay? So enough of the advertising. Here are our customers. Just give you a perspective so you kind of know. All right? Okay. So now I wanted to talk about a solution, technical solution. Give you guys a perspective of a business problem, maybe give you a little bit of the insight on how a company would think about solving a business problem, what we did, what thought process we went through, and then the solution we came up with. So, Internet of Things. Anyone take a guess what you think this is? You got shy? The guy that has ADHD. I know you're itching to say something. What do you think?
Honestly, this just reminds me of okay, did you ever watch Star Wars 1?
Yeah, Star Wars 1, yeah.
It reminds me of the scene where it's quite under the Darth Maul fighting in that one place, and
So it's connecting things to a network, right? The things are out there, right? You can have a plane, a train, an automobile, and boy, oh boy, what did Volkswagen, for example? What if Volkswagen had the capability, right? You guys all know Volkswagen has that issue with the diesel cars, right? That, hey, they basically trick the system for smog, and they're polluting a lot more than they should be. So they've got to go in and update software. I think it's up to 12 million cars now. But what if those cars could connect to a network, like you can in a Tesla, for example, and you could update that remotely, securely? I think I can tell you it would save them $5.9 billion with a beat. Now, who knows? They're probably going to solve the problem, this PR problem that they have. Who knows how much that's going to cost them? But just the technical problem. By the way, anyone have a Tesla in here? You're on the path. Trust me, you'll get there. We're the software company that allows them to remotely update their cars. And I don't know if you know anybody who has one. It sits in a driveway, right? And let's say you want an extra 300 horsepower. You can put your credit card, go on the web, put it in there, push a button. Your car's sitting in your driveway or plugged in, in your garage, what have you, and it will download and over the internet and download and update your automobile remotely, and you will have that extra horsepower or extra feature. It's pretty cool. So that's the thing, and the internet helping connect those things. So let's talk a little bit about what you guys might see, right? So the way it used to work, development, right? Embedded development or thing development, you had some guy over here, right? And you wrote compiled code, and executed that code in a target. Does this look familiar? I think you guys probably know this model. No? Yes? Yeah? And then, you execute the code with the executable code was downloaded and debugged with some tools, right? And then if you had some embedded device, you got to see, hey, did the light blink or not? And you had to start all over again if it didn't do what you needed to do. Right? That's what happened. Well, then the designer said, okay, now I'm done with that product, now go work on the new thing. Right? That was sort of this embedded development. I went to work on the car, now I go work on the new thing. Because I have no way to communicate with that device. Well, in our new world, we live this today, right? Connectivity is everywhere, right? And I don't know if whoever you believe here, I mean, we've got, 5 billion connected people around the world. We've got 15 billion devices that can be connected. That's a lot of devices. Tons of things. Think of anything, right? From your camera in your house to the ability to connect with thermostats and air conditioners, these kinds of things. And this is a lot of data too. So the goal would be, can you do anything with this data? And so we kind of look at kind of the new world, right? We sat around and looked at when we said, hey, we're in 3 billion devices. We know that a lot of these devices, if we could connect them, you could do some pretty cool things, right? Like for GE, for example, we went to GE and said, hey, would you be interested? So we were thinking about, as technologists, before you go build something, you go validate. You don't want to spend millions of dollars on developing. You go talk to people first. We went and talked to the head of GE's aircraft engine division and said, hey, do you have computers in the aircraft? We know because our software runs the computers that control your jet engines. You have an IP address. We know that because we built the software and it communicates internally in the plane, right? Well, what if you could communicate other data about that aircraft? Altitude, air pressure, moisture in the air. And then you could actually go report that back to a central system that was connected to a bunch of planes in the air. And you could figure out what altitude was the best for lowest or the most velocity, right? How could you reduce the winds, or reduce the ability for the external forces slowing that plane down? What would be the most efficient altitude? And if anybody knows anything about an airline, 90% of running an airline is the fuel, right? So what if you could create that network? Well, of course, GE said that'd be a home run. That'd be awesome. And so we had this idea that we could go back to our customers who had our software and these things, and we could think of new creative business models, and we could help them solve different business problems, right? Going from this development to a different kind of development. So we went to our customers and we said, hey, think about this. What if you could write your code, and like you saw that first code, and you would create that code and you could simulate and put that in the cloud first. And the reason why you want to do that is so you have the ability to not only do this more efficiently, but you have also the ability to start to create a device-to-cloud connectivity. Because you have the cloud to be able to start to connect to all those things out there, whatever those things are. The other thing is that you can let those devices log in, if you will, or authenticate in the cloud with nobody there. So you wouldn't have to take somebody to go and log your Tesla into the cloud. It would just know that that Tesla was safe to log in. Here was the parameters. Here was the permissions, right? And they could provision the right assets that would go to that device. And then you can create a whole system of networks. And we know today that connectivity is pretty cheap. And we have pretty much wireless connectivity in most places. And we definitely have cell connectivity in a lot of places remotely. So what if you could apply this, some of the new things that we do, and connecting these things through that network infrastructure to a data center? So what if you could think of it that way? Because most of the stuff that we built, those several billion devices that we have out there, weren't really connected to the cloud yet. But we knew how to do it. So like I told you before, we went to GE and we proposed, hey, if we could give you technology that would allow you to connect, that would be something that, would be interesting for your business model. And of course, they said yes. We went to Tesla, we went to Ford Motor Company, we went to Kuka Robotics, who makes robots, industrial robots. We went to 70 companies worldwide. So we figured, hey, this would be pretty cool. And we had our best software designers, our best architects, our best hardware architects figuring out what would be the right model for that. Well, in addition to that, you've got some things that are helping us, right? Because the cost of sensors, the little sensors that are going into devices, are way down in price. And the cost of bandwidth, connectivity, 40 times less than it was 10 years ago. So we had some things going for us. We knew that, hey, the climate was right. And processing power is a lot cheaper. So we could, have pretty small, inexpensive processors in these devices. So we had a lot of the right things. And so I assembled a team together. We invested about $30 million. Like I said, we took a lot of, I put my best and brightest engineers and designers on it. We hired people from the outside. We said, hey, if we could solve this problem of connecting those things to the cloud and helping customers feel like that it was secure and that make better decisions, we thought there'd be a huge business for it. So, not just us right here, and we came out with a product, and it's called Helix. I won't get into the details here, but I think what you see on the left here, you see all these devices. Where it's red is where we have software. And if we can help those devices, whether they're industrial robots or a car, like I said, a plane, connect through a gateway and then a network, we would have software on the cloud that could help customers provision and act on the device as they need. Okay, so when we talk about the jet engine, hey, it was GE who has the cloud up here, our software runs on the cloud, and helps GE make better decisions about where they would put their aircraft, right, their customers, like Lufthansa or United, and they take a cut of all the fuel that they save for them. And they have 5 airlines using it now. So, you think of 1% savings of, hundreds of millions of dollars, it's a big number. So, this gives you kind of a schema there. So today we've got about 125 engineers on this project. We've got, 175 customers already. This is generating $80 million a year revenue, this model. And my sense is that this could be a $1 billion company. So let me give you some other use cases here. Who likes beer? So those are the only people who aren't lying, because there's a lot of them. So we worked with a startup called SteadyCert. And actually, this was a bunch of people that used to work for Wind River. So they were working in this group, and they had this idea that if you go look at the beer industry, there's a problem with inventory. Because today, I don't know if you look at how a bar works. Many of you guys have spent time in bars, I suspect. Anybody work in a bar? Great place to make money, by the way. I did that in college. So, how people, do you know how people tell if the keg is full or not? They shake it, right? And they also don't know, how low is it? Because you don't want to let it go all the way to the end before you change it, because it gets all the foam. So they shake it and say, oh, it's about done. We'll pull it out. Right? That's how it's typically done, stock rotation. The other thing is that when they do that, 5 to 10% of all beer keg goes to waste. That's a big waste. You think about it. The guy who likes beer, that's a really big waste. That feels like a crime. So you can't really tell. It's all manual. So we had a bunch of smart engineers who left the company. We helped them with software, create a solution called the iCake. And I'm not kidding you. This is a real story. You guys think I'm lying. I think you guys look at me, no way. It's true. And it helped people really with the whole management, stock rotation. Did some other things too when we started implementing. And here's the solution. See down there's a little, it's actually a sensor where the keg goes on top. And it knows exactly the weight of beer. So as beer leaves the keg, it knows exactly how much is full. We have a wireless, remember we talked about the gateway? You saw that wireless gateway that uplinks to a cellular network. And it interfaces with our cloud, it's branded their cloud, and the retail and the distributor. So the distributor can see how much beer is being sold and what's being sold. So they would know, hey, when I show up, I know exactly what beer to bring. And the retailer can say, hey, you know what? No one's buying this beer here. I should do stock rotation. I should stop selling this beer. They can also do things, now they're starting to sell the data. So the company called, the company that produces iCake, which is the name of the product, starting to sell its data to distributors. So they can say, hey, in these particular geographies, I can tell you to the minute what beer is selling. So when you do an advertisement or do something online, I can tell you how it affects beer sales that day. So this company is actually taken off. So if you want to invest some money, you can. You probably should. But innovative, IoT, an industry that's not connected. You can think about things. This is a simple example. Okay? Here's another example. Anybody know this company? Largest trucking company in the U.S. How many trucks do you think they have? Take a guess. How many trucks do you think they have? It's a lot. Good number. A couple 100,000. That's a lot, but not quite a couple hundred. That's a good guess, though. Really good guess. So these guys have 10,000 trucks. That's a lot of trucks. Okay? So what do you think their biggest issue is? Fuel. Right? Not much different than the airline. So what they really needed to do was to improve their gas mileage. Right? They also have this thing, is that the trucking industry is heavily regulated. So they can only work a very minimum amount of hours. So it's 6 driving. So they need to take a break. If they work over that 6, they have to pay overtime. And what they have to do at the end of the day is fill out about an hour's worth of paperwork. Where they went, what they dropped off, sign off a bunch of stuff. It takes them about an hour. They said, well, how can we cut that cost down too? So we worked with a third party called Vinomics to embed a solution that can communicate, put some sensors on the truck, and that can communicate with that truck through our cloud and make different decisions about and give some interesting coaching on how you might shift. So this is the panel that Vinomics puts into place. And our software populates this data. And essentially they do 2 things. They do a shift light on how to shift, and they give them coaching on what's the time to shift and how much gas they should be giving. Second thing they do is they really monitor this because they measure and they put pay, or the driver's pay associated with how well they follow this. And and it takes down data. By the way, the other thing this does too is it takes down a bunch of data of where they've traveled and all the manifestations. So at the end, they only need to spend 10 minutes doing the paperwork versus an hour. And here's the results. This was actually pretty cool. So they rolled this out to a pilot in the first 6 months to 2,000 cars, or 2,000 trucks. And they estimate that if they were to roll this out to their entire fleet, they get a 6% increase in gas mileage, and that would save them $15 million every 6 months. That's $30 million a year. That's just pure profit. So this is getting things, taking the right data off those things, so you can make better decisions. Okay, so let's talk about success here. Here's the one thing that's been good about sort of my time over the last 20 years or so of my career. I probably interviewed 1,000 people to give you a perspective. And when I look at success, I'll ask you, how many of you guys working full time? Half part time? Not working at all. So most of you guys are working, right? How many of you guys would say that you have to put yourself through school, that you actually have to afford what you do? It's not given to you. Raise your hands. Okay, so 30% or so. So this journey, which you guys are going through now, I think fall into 3 things that make the most accessible employees I have. And I'm telling you, it's not where you went to school. Not at all. It's not, quite frankly, it's not your GPA either, although I don't know that that's a popular comment to anyone who's a professor. It's not your GPA. It absolutely isn't. GPA may tell some things about you. I know I was working full-time, working really hard. It's a lot harder to get good grades when you work full-time, and you have to go to school full-time. This is not easy. So I can tell you the three things that I got the most out of this experience that I know now, I'm old enough to know, and spending enough time at executive coach, which is really my strength, right? You know enough about what made you successful or not. Are these three things: grit, your growth mindset, and resiliency. I mean, the time I'm spending, I remember kind of about, I'm kind of going back there, so I'm 20 years old, I was living in the garage of a friend's house because I couldn't afford rent. I mean, you go through stuff that's kind of crappy, but it sort of builds character. Because the day, I mean, how many of you guys want to be, are you guys at startups or anyone in a startup? Technology companies? No? Nobody's at a technology company? Okay. Right, so I mean, part of this is, change, and there's a lot of velocity that your guys might be going through. If you aspire to be at a startup, aspire to be a technology company, change is happening. It's hard to work with these companies. And a lot of that we go through at work is nothing compared to what you guys are going through now. You know this woman, ever heard of this? Yeah? Do you guys talk about her?
No.
But you know.
I just saw her, yeah.
Okay. But everybody knows that or no? Just you were saying out loud just because you want me to know? Okay. This woman's great. I don't know if you can go. She did a TED Talk. I've actually met her in person. I invited her to my place of employment, Wind River, and had a couple-hour conversation with her. She did a bunch of research on what really makes people successful, and she said that grit is the number one. Your ability to be resilient, your ability to kind of go through tough things, your ability to go and say, hey, you know what, screw it. You can't tell me no. I'm going to be there. And I'm going to be the one that's going to drive, my destiny. And while I don't have all of the, sort of maybe background, or maybe I don't have the financial means, I'm still going to get there. And just going through that process, when you get to a place, and many of you are already there, but as you get there, this is the thing that makes you successful. One of them. And I can tell you, some of my very, very, very best employees, very, very best executives, I have a person on E-staff, went to JC, worked really hard for 3 years because they couldn't afford to go full-time, then ended up going to Santa Clara. She's fantastic. She went through the same process. And she's tough as nails. She always laughs and says, all these, did anybody go to Cal here? Because our office is close to Cal. She goes, all these, Calvins can't handle this stuff. They're not tough. Now you got to do layoffs, you got to reorg, you got to go and you got a crisis, the customer's really pissed off, right? You got to be able to go and handle that stuff. The other thing is a growth mindset. Did you hear about this woman here? Carol Dwight, do you know her? Yeah? Study her if you don't know her. She did a lot of research on, you've got kids coming from multiple backgrounds. How do we have kids in the inner cities do so well? How do we have, what's the mindset? And a lot of it has to do with, she talks about the power of yet. Meaning, hey, I'm not done yet, but I'll get there. And she talks a lot about this whole notion of fixed mindset versus growth mindset. A lot of it has to do with an attitude. And the people that go through really tough times and make it out of it tend to have a growth mindset, right? They don't say your skills are something you're born with. They say you work at it. Talk about, I don't know if you guys know this, right? Opportunity, is about persistence. It's about, hey, kind of working towards the goal versus, being, kind of given something, right? And this lack of skill set that's going to, kind of be, help me not get better because I've got to focus on the challenge, etc. And she talks a lot about this whole notion that if you can always have a positive attitude, and you can always, kind of, you've been through a kind of maybe a little less, kind of easy way. Oftentimes, those folks that come out the back end are much, much, much more successful. So, I mean, I'll tell you guys, if you didn't know already, I think the path you're on is a great one. I think you have to leverage it as much as you can. You can come from a junior college, you can go to state college, you can go wherever you want and still be successful. And I think, quite frankly, if you kind of leverage the resources at this university, I think you can, and the people who went here. I also don't think the alumni that maybe have or have gone through and been successful reach out enough. I think that's an area where, I can tell, but I think you guys don't do a good enough job with that. But I think there's an opportunity to connect better. And you guys are on the right path. You may not see it, you may feel really crappy right now. Crummy right now, sorry. Really crummy right now, but you guys are on the right path. what you're going through is going to help you on the end. So with that, take questions.
Don't we offer internships?
Yeah, we do.
Is there a website that would let me go to find more?
You can come out and view my car.
Oh, very good.
Yeah, I think we had 3 or 4 people. They did a great job for us, by the way. They were the most competitive, I'll tell you that. It was great. And you know, we had a cohort of individuals that were there. I mean, I'd like to compare, but we had a cohort of individuals, and there were 2 that were super tough. So really, really good. So I'll give you my card. You guys can send me these.
You're talking about how all of these objects or everyday things have connected to the internet. Where are the servers that are like holding all of this information? You know, because everything is connected, and it has to be stored somewhere. You know.
So when things get connected, it's in a cloud. It's in a cloud. Yeah. But a data center, right? So you've got public data centers, you've got private data centers. So for us, you know, we've got 7 big honking data centers all around, the world. Many others. I mean, I don't know if you guys know this. The biggest, there was 2 things. All used to be manufacturing, data centers and heating for all of the HVAC systems we have for large buildings. Way more pollutants than cars. It's like 10x. So data centers are not that eco-friendly, by the way. But yeah, it's all of these non-eco-friendly data centers all over the place. Yeah.
There's a lot of such coverage about people hacking into
Well, they don't use our product, the ones that those got into. So that's a great question. So you talk about either the Honda or the Jeep. So there's a couple things. One, treating a car like a mini data center versus the way it is today. Like today, you have what's called a CAN bus, and the way those cars were hacked into, they had basically the satellite connectivity for the kind of your phone home. I don't know if you know, kind of you can push the button and you'll call and get your what? Bluetooth. No, well, it hacked first initially through the OnStar equivalent. And it goes to the CAN bus. Then Bluetooth goes into the additional systems where you have access to turn on and turn off things. So there's some pretty simple things you can do with like a simple firewall that cars don't have, and a domain like cars don't have, or separating systems, time and space partitioning that some of those systems don't have. So there's a bunch of things, and we have a product called X-Drive that a lot of cars are implementing now that have a absolutely secure internal. And by the way, one of the things that we do is do the avionics for jet fighters and commercial aircraft. So there's a similar thing, right? You would want to be able to hack into there, and those I wouldn't say it's never hackable, but we've done some things there to make sure you can't go take over a jet. It's a good question. Autonomous driving, ADAS stuff? Yeah, absolutely. Absolutely. A couple of things around sensor fusion. So you have all of these sensors in your car, right? You can have a backup camera, you can have a camera back, in the back. You can have your cameras around the sides, camera in the front. Taking all that data in, or any LiDAR data in, and then making different decisions, like put the brake on, what have you. Trying to condense that down, because if you go look at some of the autonomous cars now, they gotta have a freaking data center in the back. And it's really hot in some of those cars. There's, they don't get terrific gas mileage because you have to have a air conditioner on full time in the back seat. So we're trying to do things with multi-core processing and some miniaturization of some of the CPUs and things. It's not. Anyone work at Intel here? Okay, good. Our parent company doesn't like what we're doing because we want to try and collapse some of the CPUs to SoCs because they're a lot more power efficient. But a lot of stuff. And some stuff I can't talk about, but some stuff I can. But a lot. We're actually in the Google car. They don't let us say that, but I just did.
How safe is data in the cloud?
That's like one of those philosophical questions.
Yeah.
So one of the things I also have, I have a top secret clearance. So, since we do so much with the military. And so I would say, if you listen to a bunch of stuff, it's not. I think if you have a private cloud, it's a lot safer versus a public cloud. I think meaning that, you have your own data center versus one that's external and that, you can use, run, or borrow, or ride on top of, like Google, their data centers and things. A lot safer. I don't think it's ever safe enough. I think anyone that says, I'm in Stanford, that's really safe, I don't want to be quoted as that. I think the private cloud is much safer, just based on the topology and the fit. And I would also say that so the good news is embedded devices, you can lock those down to be incredibly safe and secure. Now, you lose some things, but you gain some things. So I think that, with our ability maybe to think a little bit, say, less open, more safe and secure for certain kinds of things, making some trade-offs, like not using Linux, for one. Not that that's bad, we have a big Linux business, but there's a lot of things you can control if all of your OS isn't open, or your middleware, or whatever. So I think some of that stuff you can control, but I think it's really safe, very, very safe, but you can always have someone come in and do something to breach.
I was just wondering, do you guys use kind of scenarios as to, because I can have some hacker name or some kind of, something that works, and, doing something where, that it could be able to manipulate other people, not necessarily do that. But it's never, it's possible.
Yeah, we do, and we work with our customers too, especially since we've done so much stuff with the military and aircraft. I mean, that's kind of that higher level, especially if that aircraft carries munitions. So there's a lot of things we do to detect. And we also do things like we secure every line of our code. So we spend for the applications for safety critical stuff, we'll spend, $39 million a year just certifying every single line of code and locking it down in certain ways. So we do a lot. It's probably never enough, but we do a lot.
So for jets, for the companies that you mentioned United and Lufthansa use a private jet, so very more. So they pretty much shouldn't have any delays because their fears should be fixed within their cloud and all the delays and now it's usually right.
Well, here's the difference. So you remember, you've got traffic, and you got, there's so many more planes in the sky now. I don't know if you guys, maybe some of you guys are old enough. It used to take, just to get to LA, it would take less than an hour. It would take 47 minutes to get to LA. It's more now, because more planes, more traffic. And sometimes, with any kind of weather, you get SFO here, you get the fog, you get the wind, they shut down, and then you have international traffic, so they shut down the other, kind of potential paths, right? The software's not going to help with that. I mean, Mother Nature kind of gives us a bad draw there. So we don't help with that. So we're going to tell them the optimum elevation within plus or minus 2,000 to 4,000 feet that they should fly to save or be most economically fuel efficient. We can't help with the delays, unfortunately. And they only go so fast. That's the other thing, right? We might say go 5 knots slower. So theoretically, we might delay it a little bit. Any questions?
So the guys that you have pretty much the electronics, could they be also able to have the potential to have a kill switch? Where if something's not working properly on it, it'll actually deactivate that plane, the car. Do they have that potential?
What, you mean a hacker?
Yeah, I mean hacker within, so they have that potential?
So here's the thing that we do. That's a really, really good question. So for certain safety critical or real-time functions, we make them fully deterministic, which means they can't fail. They're locked down, you have no access to control. So for example, the throttle in a car. you probably want that locked down that someone couldn't take over. You can pick certain functions. This is the gentleman asked this question about, hey, could you know, cars that got hacked and what happened, and how would you make them more safe? We would take certain functions and you lock them down, you have no access to them. Zero access. So if you do that, you minimize the amount of things that someone could take over, even if they could. So, you know, today, if you go look at some of the cars, I mean, they had that kind of hackathon conversion that made how fast can hackers get into, you know, a car. So, you know, the CAN bus allows you to have, which is basically your network, right? Access to everything. Well, you know, you could turn a lot of that stuff off and say you don't get access to everything. And I think that's going to change the way in which cars are made. And that's actually better. I don't know if you guys know much you know about the automotive industry, but it's very old school. And it's not very software oriented. And they're still using a lot of old practice. I mean, they used to use waterfall programming. I don't know if you guys know versus agile. They don't use agile. You know, I mean, it's disaster. If we didn't use agile, we'd be out of business. So I think that they're going to have to change stuff. This is going to make them build better cars and safer cars.
For the, I guess the robots, like what does the software do for those? Like figure out if they're working properly or if they're putting parts in the right spot? Like, what does the software do for that?
So you, a few things. One, you've got the pattern. What are programs? What are all the coordinates of what that robot has to do? Whether it's drilling a hole, whether it's soldering or something, welding something. There's that piece. And so there's also the speed. How fast do you want to do that? The latency, like the time between tasks. And then the deterministic behavior, like something can't crash. Like if, for example, you have a if-then-else that said that if someone's hand got close to the laser, that's you know, 4,000 degrees or what the hell it is, it's going to cut through the metal, and it would turn it off before it got to, you know, before the hand went through it. I mean, some of this deterministic behavior, that's what the software does. So it's really, you know, we separate, you know, the functional process and there's the data process. And the data would be things like how someone would interact with that robot. Oftentimes that would be running on a Windows PC. And then all the control function, the real-time deterministic behavior, we handle with our software. All of the execution of coordinates, and ensuring that, you know, man and machine don't come together in a bad way. There's lots of sensors around. I don't know if you've seen those robots, they're huge. Yeah, so you don't want to be hit one of those. Anything else? Excellent. Thanks, guys.